In this hint, I'd like to talk you through this set of cost graphs. On the left, we have the total cost graphs. So we're measuring total cost on the y-axis and the quantity of production or output, in this case, quantity of earrings, on the x-axis. The easy one here is fixed cost, which is simply fixed at a certain level, in this case, $50. So no matter what the level of production, the fixed costs do not change. This, by the way, tells you that we are in the short run. Whenever there is a fixed cost, that implies a fixed input to production, and that tells us we're in the short run. So in the short run, we have both fixed cost and we have variable cost, okay? And what this graph is showing is that variable costs grow like so, and then they begin to grow more quickly. Do you see how that begins to curve upward? Okay. And then total cost is the sum of fixed plus variable. So we simply shift the variable cost curve up by the amount of fixed cost here, by 50. Okay. So this curve, total cost, is variable cost plus 50 at every single quantity as we go along the x-axis. All right, now when we look at the graph on the right, then you see marginal cost, and we see various versions of average cost: average total, average variable, and average fixed. All of these are being measured on the y-axis. So let's talk about the easy one first, the average fixed cost. Now, the average fixed cost, we find, is always getting smaller, smaller, smaller as quantity goes up, and it will continue to approach zero, but never reach zero. This is because you're taking over here this fixed cost of $50, and you're dividing it by a quantity that is getting bigger, 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 bigger. Therefore, the average fixed cost is getting smaller, smaller, smaller. The next thing we'd like to look at is the marginal cost. Note that it goes down and then up, and it reaches its minimum point right around here, which is somewhere around 15 units. Now, I have redrawn the total cost diagram and put it right below the marginal and average cost diagram in order to illustrate the following. The minimum point that we noted for marginal cost, right around 15, can now be brought straight down to the x-axis of this total cost diagram, because these axes, the quantity axis here and the quantity axis here, match. Okay, so the point that I would like to make that is a little bit hard to see in this upper diagram here, so I've kind of exaggerated the shape of the curves down here to show you that up to 15, the total variable cost curve is going up slower and slower, and then once we get to 15, it begins to go up faster and faster. Okay? The total cost curve shows the same pattern because it's being really driven by what's happening with total variable cost. Total fixed cost, of course, is irrelevant in this regard because it's not changing at all. All right, so we call this, by the way, an inflection point, if you remember from your math. So this is where the slope of total variable or total cost stops going down. So the slope is positive, but it's falling because it's going up slower and slower. And it begins to, it's still positive, but now it's going up faster and faster. Okay, so let's go back to the marginal cost curve, and you'll see that it's falling until 15, and then it's rising. So in fact, the marginal cost, when you think about its definition, delta total cost over delta Q, you can see that this is the slope of the total cost curve, or the slope of the total variable cost curve. It's the same thing, right? So the marginal cost is the slope of the total cost or the total variable cost curve. The final thing I'd like to show you in this diagram is the relationship between this marginal curve and the average variable, average total cost. Again, average fixed cost is kind of an outlier, so we're not going to worry about it. It kind of does its own thing. Now, for average variable and average total, note that they cross the marginal cost curve exactly at their own minimum points. Okay, so this is the minimum point of average variable cost. This is the minimum point of average total cost curve. That is where they must cross the marginal cost curve. Another way to think of this is as long as the marginal curve, this orange one, right, is below the average variable or the average total cost, it is pulling those curves down, okay? If that marginal cost here is above the average variable or the average total, then it is pulling them up. Remember that the marginal is your active agent here. What's happening with the marginal is what causes the shapes of the average variable and the average total cost curves. Recall the analogy we used with the grade point average and the marginal grade. So if you're taking one course in a semester, we consider that the marginal grade. And if you receive a grade in that course that is above your grade point average, it will pull your GPA up. If your marginal grade is below your average, it will pull it down. So that is the same thing we've been talking about here, that if the marginal is below the averages, it will pull them down. If the marginal is above these averages, it will pull them up. Okay, so I think we have a good overview to all of these cost graphs. This is a copy of the chart from the book where we have all of our cost curves defined. Here's all the definitions, and the equations are here. I wanted to point out that there's a typo in the book for marginal cost. This should be the delta TC divided by the delta Q. That's very important. And the delta Q was left off, so make sure you correct that in your book. And then we have total cost, fixed plus variable. We have average total cost, which is total cost divided by Q. We have average fixed cost, which is fixed cost divided by Q. And we have average variable cost, which is variable cost divided by Q. This completes our review of cost curves and concepts.